Okay, good afternoon, everyone. Welcome back to the fourth class. Surprisingly, I thought it would be three class, but this is the fourth class. Anyway, today I'm going to talk about three state of the art in deep learning architecture, and in the end of this class, we might have some time to update your project, your progress a little bit. Okay, for now, I will start with this one first, word to vec. If you think about transforming something, like if you have some kind of text and you want your machine learning to learn something from this text, to extract something from that one, it might hard if you keep that thing in the text format. You may have to transform that thing into some kind of number first. Let's consider the categorical data type here. If we think about gender nowadays, how many gender do we have? Well, a lot. Of course, we have female and male, and demigirl, travesty. I'm not sure the definition of each of them. Anyway, there are a lot of them. But let's think about some kind of machine learning like linear regression, where you have your x, which is input, and multiply with some coefficient here, which maybe you can call it weight, and you may plus the bias or the intercept. You get the result here. But this is a number, right? This is number. But if you put this thing, female, male, into replace this x, well, you cannot do anything with this text, this thing. You cannot do anything. If we want to do something, we have to find another way to represent this thing. Well, maybe we can replace this one with number. For example, here, I replace the female with 0, male to be 1, and demigirl to be 2, right? This one. Well, if that record is from female, actually we don't know yet what we are going to do now. But if that record is female, you can put the 0 here instead of x and do some kind of multiplication and addition here, and you get another number. If that record is male, you can put number 1 here and do something with weight and bias here. It seems to be okay. But if that problem is about who have a higher risk of breast cancer, well, let me guess. I think female here and demigirl who might be naturally born in female body. I'm not sure for this. Gender queer, maybe 50-50. if we form the model like in this formula, we introduce another problem if we use this kind of representation. For example, well, if there is female number 0 here, right? The probability should be look like this. If this is 1, if this is 0, this is female, and this is male, and so on. For female, it should be decreasing from 1 to 0 at male here. And for demigirl, maybe it have to up again. And I'm not sure for travesty, maybe down, and genderqueer, I don't know. This we cannot find any way to satisfy this function. We introduce non-linearity into this one. We may have to create this function. For example, this W1 and bias, and maybe W0 for female, plus maybe W1 plus W2, something like this one. So to represent this categorical data with the number, I don't think it's gonna work. We transform the nominal scale here to ordinal scale, which is not correct. Another way to represent it, you can hot code it. To hot code it, we have to create another dummy column. For example, at first, it may be female, male, demigirl, and so on in one column. Let's imagine that this is Excel. This is one column. Instead of doing this, we may have to create another dummy column. For example, I'm not sure how many genders here. Let's say we have 3 genders. It's maybe four. Female here, male, demigirl, and travesty, this one, and which one is female? We can fract this one to 1. The rest will be 0, like this. For male, you fract this column to 1, and the rest will be 0. To do this, we not transform this data, the nominal scale into ordinal scale, which the ordinal may have influence in the target. But to transform it this way, it will solve the first problem that I mentioned earlier. It looks good now. If we have something like categorical data type here, but let's think about a word here. Now consider 6 words. Let's say we have 6 words here. I am man, woman, boy, girl. And we use the same way to encode this thing, to hot code it. For I, it will be 1 and the rest is 0. For am, it will be 0 and 1 and the rest is 0. It should be okay, right? However, in word is not that different between man and boy. Well, there is something similar a little bit. It's in the same gender, right? And for woman and girl should be in the same, having the same gender. There is some aspect that shares some aspect with the other, but if we represent these 6 words using hot coded this way, and if we measure the distance between each of them for man and woman, as I show you here in this code, I use the cosine similarity, which is one of the methods to measure the distance between 2 vectors. If we represent this one using this vector, let me compute the distance between man and man, which is the same, right? Man and man, the similarity is 1. That means it is the same vector. But for man and woman, it's 0. It's totally different. And for man and boy, well, 0. Totally different. Well, maybe man and boy should be, there is something similar, right? As I mentioned earlier. So if we represent a word using this way, it will not be the best way to represent this word for machine learning to extract some information from it. Let's consider the real world situation. When you want to scrape a text from social network, there is a word that, for example, good, best, magnificent, excellent. It actually should be categorized into the same group, right? With a positive sentiment. But if we use this way, well, it's quite hard to find the similarity. You have to, well, define the set of words that should be in a good sentiment, which is quite hard. Word to Word, that is where it came from. In this problem, we want to create some kind of model to learn to embed the word into a vector form. And that is word to vec. In word to vec, you just have to create some kind of model that feed the word. We have word here. We feed the word into this model, which you might transform this word into some kind of number, maybe number 0 to maybe 1000, something like this. And this model, the encode model, will transform this number into some kind of vector. The dimension of this vector is up to you. It's arbitrarily defined by the user. But the problem is there is no right or wrong now to find a way to encode each word. For example, if you put the word man, how would it should be? It should be 0.5 at first, or 2, or 3. There is no correct way to do that. Well, but if we want to do that, we don't do that thing directly. We create another model that feed this word into this model. It is language model, and you use this model to do some kind of task. If this model do that task well, it should reflect back to this model. If it is not, the feedback will also back to the first model. And the way to do the task, there is 2 ways. First way is called back of word. The back of word, the task is this model is how to predict the middle word from surrounding context. For example, if I feed this model using this sentence, at first data point, okay. At the first data point for training data set, I might feed this one and remove the middle one, and ask the model to predict what is the word here, what should be the missing word here. And then I slide the window to the next step and remove the middle word here. Again, let the model guess what should be the word here. This is the first way to train model, the back of words model. Another way to do that is called skipgram or maybe n-gram model. In this way, we feed a certain length sentence like this one, and ask the model to predict what will be the words after this string, and then do it again. Move the window, and again and again. This way will also teach the embedded model to transform this word. If this model do the task well, it will reflect into this one. So now I will show you the way to train skipgram model. But don't worry, you don't have to train it from scratch. There are pre-trained model, and you can use that one. You don't have to retrain it. I will show you. In this class, there is so many libraries that you can use to create deep learning model. For example, you can use NumPy. You can write your pure Python code, but I'm not suggest you to do that, you can use the TensorFlow or Keras. But in this class, I will use Torch, PyTorch. First, you have to import Torch, and as always, do set the seed so that this experiment will be redoable. If you want to replicate this experiment, rerun it, the result will be the same. But if you don't set it one, the result will maybe change a little bit. If you want to rerun it again, well, maybe you may have different result. So always set the seed. And this is, for example, to the way to embed the word. First, there is two words here. I divided two words here. And the first word, hello, must be in number 0. The world must be in number 1. And I create the embedding model here, receive two words in vocabulary that transform this word into 5 abstract dimensions. After you do this one, you run this one, it transforms the number 0 to something that looks like this one. And you can feed this one into your model. But well, actually we don't train anything yet. I just want to show you how it will look like. It should look like this. This is the way to train n-gram model. At first, I define the context size. I will provide them the model 2 words. For example, it's from this sentence, when 40 winter. At first, it should be like when and 40, and you have to predict winter like this one. This is the context. This 2 will be the number of context. And embedding dimension, after we embed each word, the resultant vertex will be in 10 dimension, in 10D. Okay, and this is the sentence. This is the training sentence. I don't know what it is, but it appears to be from Shakespeare Sonnet 2. I never read that before. But we got this sentence. We have to transform it. We have to transform the data set first. We just tokenize each of them. We split it by space here. So the result from this one will be a list of string. The first one will be string when. The second element will be 40. We do this and we create the first data set here, which I will show you what result look like. From this one, the result will be look like this one. As I mentioned earlier, the context size is 2, so there is 2 words. 40 when to predict winter. And the second data point is winter, and 40 predict shall, and so on. Now the data set is ready. We are going to replace each word. Actually now it is a string, right? We have to transform this string into some kind of number. For example, maybe 40 will be 0 when will be number 1, like this. And in this code, this is actually a model that we are going to train it. You can use this code if you want to do the word to word. But if you want to retrain it from scratch, you can use this one. Anyway, I will not delve into the detail. You can spend your free time to read the code, because in this course I want to talk about the way to analyze things first. We're not in computer science, right? It will not. I think it will be too much for you. But actually, it's not that hard. You can read it by yourself. Now, with the torch framework, you already define the model architecture like this one. Now you have to define the load function. You can just doing this. This is load function. And you create your model. And by this model with the optimizer, in this case, it is a stochastic gradient descent, which is some one kind of optimizer. You have to put all parameter into this optimizer, and the learning rate, it can keep this thing as a default. And after that, you have to train it by each epoch. You have to define the way to train it. At first, the total load is 0. And then you have to, the first step, you have to feed the data. You have to transform the input into some kind of tensor using this line. And then you have to clear your model gradient using this one. Because after model learn something, after you feed the input into model and you back propagate, there will be a gradient of the model. And after that, you will ask the optimizer to find the better place to adjust the parameter of this model. So before doing that step, you have to clear the gradient first. So that's why you have to call it method. And then you run the forward pass by sending the input into the model. You get the probability, and you compare the result from this model, the probability, with the actual one, like this one. You get the loss, then you back propagate each loss into its model, if you don't get it yet, what backpropagation is, what feedforward is, don't worry. You just follow this step. But you can revise the class that Dr. Pumchai teach you about neural network. And after that, you run this step. The optimizer will adjust the parameter of the model. This is the way to train the model in one epoch. You keep doing this until 10 epoch, and then this one will show you the loss, and this one will show you the way to embed the word beauty, what it looks like. And this is the loss of the model. And you can see we start with this number 522, and then the number is decreasing. That means the model is on the training. I think you can keep training the model until maybe 100 epoch, something like that. And this is the resultant tensor, the result from embed the word beauty. The final result will be look like this one. You will not get what we are going to use that. I will show you later why this way, this representation is better than the first one I mentioned earlier. Okay. And well, actually, you don't have to do that by yourself. You can use the pre-trained model. At first, you may have to install so many packages here. You just run this block and wait for it a little bit. Okay. And we are going to load the pre-trained model that called Grovy. I'm not sure how to pronounce that, but we can use this one by just doing this. Okay, it will take some time, around 3 minutes after this is done. You can, after it finished loading this one, you can use this object to encode any word, but in English. In this model, there is 400,000 unique words in Grow vocabulary, but every single word it must be in lowercase only. That is, you have to be aware of this one. And before you pass your words into this model, you have to transform your word into some kind of number. This instruction will show you what it looks like. I'm not sure. Maybe this one. this one with this code will transform the word the to a number, which is 0. But let's wait for the load here. Almost. Oh, actually, the vector from the embedded vector from this model, there is so many versions of the vector here: 50, 100, 200, 300, like this one. But in this case, the result will be in 100 dimension. I'm not sure which one is the way to consider which one we are going to choose. You may have to try that. But in this class, maybe you can use maybe 50 or 100 version of this model. Okay. It's done. It's done. The shape is 400,000. And what is this? Oh, okay. This is the list of words that exist in this model. It starts with the and comma and full stop and off to like this one and so on. And for the word the is in the position 0. So you have to transform the word into a number first, and then pass this number into growth vector like this one. It will transform the word the into a vector of in 1000 dimension like this one. And if you can remember this example, which I have shown you, if we use the hard code to encode the word man, woman, boy, and girl, there is no similarity between each word. But if we use this one, man and man, of course, it will be one. Man and woman, it will share some aspect of similarity, 0.83. For man and boy, oh, there is quite different. Woman close to man, then boy close to man. And, oh, actually, this is not man, this is girl. Okay. Girl and boy, that is quite close to each other. So I think maybe it's considered the age of the word. This is more important than the gender of each word. Well, if you're doing it right, you may you can do something like this. If there is a king, you can minus with the word woman. Oh no, with man, and add the word the vector, actually the vector from woman, the result will be queen. You can do this thing. It will not be exactly it will not be exactly this one. It's something like there is a vector of king here. This is a data point. And there is a vector of queen. You may be minus with man, it will move into another direction. And you add it with woman, it may be here, which is the closest word is queen. It will look like this. If you're doing it right, this thing is doable. However, it's up to the data set that you use for training this model. But anyway, in this course, you can use this one, as I show you here. Okay. This is the first topic. Do you have any question? You can ask me. Or maybe why we take a break. Okay, I will continue to another topic, which is convolutional neural network. As I heard from the previous class, some of your friends want to do a project that have to classify some image. If you use the model the normal machine learning, like a neural network, this is the model, and let's imagine this one is the image, which contains a pixel like this, pixel of each, and you feed each pixel into your model. Well, to do this way is quite hard. For example, if that image is in 10 by 10, 10 width and 10 height, like this one, 10 pixel wide and 10 pixel high. You may have to use 100 nodes for the first layer, which is not the efficient way to do that. In convolutional neural network, instead of feed it directly, you are going to create a layer of receptive field to do some operation on this one first, and use the result of that operation, feed it into your model. I will show you with this one. For example, if this matrix is your data, it can be your image. The number maybe represent the intensity of each pixel. For example, this one may look brighter than this one. This one may look quite dark. What it does is it creates some kind of filter which may look like this one. 3 by 3 filter, and it passes this filter through each of matrix and multiply element wise, multiply these things with this filter. So in this case, it will look like first one is 0, the second one is 97 and 0, right? Okay, it will look like this one. And you add this thing together, so it will be the result of the first one. And you move this filter to another place. This one will be another result here, and again do it again and again. However, for classical image processing, we have to define this filter by ourselves, which is, well, it's doable, but if we use the deep neural network, this number will be in randomly first, and the model will adapt the way to extract feature from your from your image. So you don't have to worry about the detail. Anyway, you can search for that later. But in this class, I will show you how to do that. Anyway, I think we should take a break, 10 minutes, and after the break, I will show you how to create model, CNN model, to learn classify CF10 dataset, which is a dataset of image that contain so many things, but having 10 class, it will look like something like this one. There is airplane, bird, cat, deer, something like this. Okay, let's see you on back in 10 minutes.